Hi, my name is Julia Udén, and I'm an assistant professor at Stockholm University and a PI in this project, which is on human-robot interaction research. In this project, we have 2 PhD students and 2 PIs, Andre Pereira at KTH and myself at Stockholm University. And we believe that well-being and health will be promoted in the future by proper social robots. So this project spans artificial intelligence, robotics, and psychology and brain imaging, which is my own area. And conversational engagement is something that is very important when you think about the quality of social robots that we want to improve, since this has been shown to lead to better pupil learning and elderly care. So what we're doing is basic research that can lead to socially relevant applications and clinically relevant applications, such as for ADHD. The problem with the current methods used to assess social robots is that they are post hoc rather than dynamic. So you ask questions after interacting with a robot, where we want to rather evolve an online measurement. Since online measurements, then you don't have to interrupt the interaction, and it depends less on which exact questions that you ask. Some experiences cannot be variabilizable at all, so then this is when this biological online measurement, such as the functional MRI measurement that we will use, is very useful. And here you see the MRI scan in the lower right corner. So in this project that I will present today, we had the opportunity to use an open database with 23 participants, and the participant was lying in the MRI scanner with an audio-visual link to an agent outside of the scanner. So they had an actual conversation, and this is one of the first times that this has been researched with fMRI. So we were very excited about this. And the agent outside of the scanner could either be a human or a robot. And then they were conversing. So they had a conversation for 1 minute, but several times. So 24 conversations in total, half robot, half human, with human agent. And the robot was a social fur hat robot that was controlled by a Wizard of Oz interface. This means that there was a human ultimately operating the robot, but they could select from different utterances that the robot could produce. So the design is that, again, we have a human or a robot outside of the scanner, and we have a participant in the scanner. And the agent outside of the scanner and the participant take turns. And this will, of course, be very important for us because we want to understand the brain processes that are underlying this turn-taking activity. So both producing speech when you speak yourself and listening to speech, comprehending speech. We defined a specific time window, a 600 millisecond time window, just before the participant was starting to speak. And this was then representing a specific process that we call turn initiation, that we also wanted to do research on. So jumping to the results, we observed more activity here in red, which is in auditory area. So this is basically very expected activity for listening to someone when you're speaking, when they are speaking. But what was not expected, what we didn't know that we would see, was that there is more activity when you are listening to a robot versus a human in these areas. So that's the activity that we are seeing in this image. And there was no similar difference between the robot talking to a robot or talking to an agent. So the difference was when they were listening. But what about the turn initiations then? Well, it turns out that the turn initiations, very interestingly, had the opposite pattern. So there we observed more brain activity in these listening areas and also in visual areas when you were just about to start to speak to a human versus to a robot. So our interpretation of this pattern is that participants spend more effort on auditory and visual input depending on which agent that they are talking to, and also the quality then of that agent, if it's a robot. So more relative effort is needed when you want to understand a robot. It can be it can require more effort for you to understand why is it saying this at this particular point. Is this perhaps an unexpected utterance from the robot and so forth. Whereas on the other hand, there is more relative effort spent on taking in the human agent just before you're supposed to start to speak. So for instance, this could represent processes related to the timing of taking turns, which we know is we know that also in this data set, there is a very short time period, only 150 milliseconds between speakers on average. And it's longer for the robots. So this very quick turn taking might require a lot of processes that involves taking in your interlocutor when you're supposed to speak. And what we want to explore then, what we would like to discuss is that this activity might actually be a benchmark measure for how engaging the conversation with the robot was, so that we might be moving away now from these subjective reports to this kind of measure. This is the first study, we should say, so we would like to continue with this. We would like to collect our own data, where we would also like to have a high engagement condition and a low engagement condition to see whether we can actually then predict how strong this activity would be. So in a high engagement condition, there would be less difference between the human and the robot than in the low engagement condition. And here we can actually use the fact that we can operate a robot to create those different conditions. fMRI is an excellent method for basic research such as this, so knowing that we can use objective measures at all, and also to distinguish between the different areas, so knowing that we're talking about listening activity versus visual activity and so forth. That has been very useful in this first project. But ultimately, we would also like to move to more wearable and inexpensive technologies, such as the EEG technology. And this current study will be an important stepping stone towards that, as in the simplest kinds of wearable EEG technologies, you have quite few electrodes, and you could then actually place them where we know that there is activity that we would like to investigate further and use for applications. So those are the future directions. We think we will get a deeper understanding on conversational engagement, both actually in human-human and in human-robot interaction, and importantly, when comparing the two. So there, I would like to thank you for your attention.